So today we'll be talking about cloud benefits. This is the second session in a series of 12 sessions for you to work on your certifications towards Azure fundamentals. So again, second session is today. The first session was yesterday. We talked about cloud computing, a few definitions we did as well. But today we'll talk about the benefits of using cloud services. All right. So a few things that you'll be introduced to, security, governance, manageability of the cloud overall, and the things that help us to be able to meet variable demand and provide good service for the cloud clients or the cloud customers. So what are some things that we need to know by the end of the day today? Some of the intended outcomes, the things we need to know the benefits or describe the benefits of high availability. Let me stand up so that I can actually speak up better. Okay, the benefits of high availability, the benefits of scalability in the cloud, as well as describe the benefits of reliability and predictability. All these words, they might be words that you see in a multiple choice question where a scenario is going to be presented to you and you'll be asked, what kind of benefit is this that the cloud provides? And then you'll be able to select which one or the other. Or maybe multiple answers might be valid in some cases. So the last two outcomes would be describing security and governance benefits, as well as describing the benefit of managing the cloud. So let's jump right in, okay? A bunch of, 7 technical words or big terms, but we're going to break it down. All right, starting up with high availability. What is high availability? Again, it's just making sure that your system is always up. Like I said, traditionally, if you decide that you don't want to go with the cloud, you want to have on-premises, you have those servers or all your services on premises. If the power goes out, you have to figure out a way to make sure that maybe a generator kicks in right away and your systems are up and running. If there's a fire or any catastrophe, you have to make sure that there's no disruption. But with cloud services, there is a maximum availability, and we'll talk about that in depth next week. But know that there's maximum availability. If your data or your server is stored in one region, they usually have it synchronized with another region to make sure that regardless of any interruption, any disruption, they have to meet that service level agreement. So they have an agreement with you that your system is always going to be up and running 99.99999%. Okay, so that guarantee is part of the SLA. Does that make sense about what high availability is?
Yeah, it makes sense from my side.
Yeah, it makes sense.
Good. So again, think about you having your private infrastructure, your private setup, hardware. If you have your car, you have to make sure that your car is always running. There's always gas in your car. Nobody has borrowed it. But that's when you have a private. But if you're dealing with a public or a cloud environment, if you need to call a taxi, taxis have to always be available, whether it's in the middle of the night or first thing in the morning. So all of those are the things that have to show that the availability is always there. It's part of your service level agreement. Okay. So that's the first one out of the way. Everybody understands that clearly. Let's talk about scalability. I think we saw a little bit of this when we did practice questions yesterday. For availability, there are 2 ways in which you can add or remove resources. So, scalability. So you want to be able to scale, right? There are some times that you might have very high demand. You want to be able to add resources to meet that demand. There are times that you have low demand. You want to be able to not waste or overpay for things that you're not using. Okay. So the 2 ways in which you can scale are either you're scaling vertically up or you're scaling horizontally. Okay. So when you're scaling vertically, as you can see in here on the slide, let me go ahead and probably use my, nope, I won't be able to use it. As you can see right here on the slide, vertical scaling means you're increasing or decreasing the capacity of your existing service. So how do you increase or decrease the capacity? You're either adjusting the power, which could be the CPU, the central processing unit, or the RAM, or maybe the storage, the size, right? So the size is increasing, but you can also increase up or down depending on the demand. That way you're not wasting any resources. Like I said, if I have a website that I'm targeting just the people in Mexico, it becomes very popular, and now everybody in Brazil, USA, and all over Europe are using it. I need to be able to increase the size of my CPU and my RAM. But then if someone else creates a very popular site more than mine, I lose all my customers. Then I have to not be using a huge amount of space or a huge amount of CPU power or processing unit if it's going to be used, or if it's going to be a waste. So I can then do it automatically and reduce the size to meet just the need of my demand. So that is scaling up and down, which is vertical. Horizontal scaling is scaling in or scaling out, and it can also be done manually or automatically. That's usually by adding instances, adding separate instances of your resource. The resources in this case, example would be a virtual machine or a container. We talked about a little bit virtual machines yesterday. Again, a virtual machine is just imaginary computer within your computer that you create and you allocate resources to it. A container, again, as we said, is a step above that. It's more.
Mr. Vitus, can you come back on the horizontal scaling, please?
Okay, horizontal scaling. So for instance, you have realized that in let's say you created a website and then you use the virtual machine to create a website. A virtual machine is like a machine within your physical machine. So as you see here, you see 3 machines on here. Each of these machines have a capacity, right? This machine could be a server with a capacity of, let's just say, for a number that's easy to remember, 100 gigabytes. With 100 gigabytes, we have exhausted all of this, and now we need to be able to get more of that. In order for us to do that, we create another instance, create another entity altogether of that same physical server, but replicate everything that's on there so that we can be able to handle the capacity, handle the demand, the number of the workload that is needed. Okay, so think about,
Right.
does that make sense?
Yes, sir.
Yeah, so that would be scaling out, because you're increasing the size, you're scaling out, you're making the number of virtual machines or the number of containers to be more. But
Which
if you
identical,
don't
right?
have, yes, that's horizontal. But if you don't have
Yeah.
that much of a demand, if you have low demand, then you reduce it by scaling it. And you can set it up, which we'll see later on next week or tomorrow. You can set it up to be done automatically, or you might decide to do it manually to say, hey, if you see that I'm running out of resources, if I'm getting to 80% or 90% usage of this virtual machine, send me an alert, and then I'll go in and just duplicate it. And you don't have to, go out and buy hardware, do all that difficult stuff, which will be the case if you're on premises or if you're deciding not to go with cloud computing. You just have to click a button or two, and then a new machine is generated for you. Simple as that. Does that make sense?
Yeah, Vitus, let me ask you a question. Oh, sorry, someone wants to say something.
No,
Yes.
go ahead, Fred.
Yeah,
If
so
you want
I want
to speak, you
to
can always just
get
raise your
some,
hand too.
yeah, to get some clear difference between. I understood the fact that you say with horizontal scaling, it basically means like increasing. That's basically increasing the machine capacity, whether by adding additional virtual machines, which are all fed from one maybe physical machine, right?
Yeah.
Yeah. And then, but with vertical scalability, is it the same? Like you use just the same machine, but you increase either the memory or you increase the RAM or you increase the storage depending on which area you are lagging, or do you also increase, let's say, add machine? You know what I mean? Let's say you have one machine now that you're operating with, and the memory of the machine is low. You want to increase the memory. Do you just increase the size of the RAM, or you're going to get another machine again? You know what I mean? Another separate machine, and then maybe stack it, and then that has an additional RAM capacity.
Okay, so very good question. Let me try to use a simple example again, like we were talking about requesting public transportation, right? Uber and Lyft. Let's say in this case, you are getting a taxi, right? When you're living alone, you know that it's just you alone. You call a taxi, the taxi comes in, just you alone can get in there. In this case, you have your small self getting in the car, it goes back and forth, no problem. But now you're no longer single. You get married, you have a big family, everybody cannot fit in that taxi. So now you need to do vertical scaling. You have to scale up. You have to call a boss, right? So now you're just increasing the number of seats in your transport vehicle. Now in that bus, there's 18 seats or 10 seats. Everybody in the family can sit down. So that would be vertical scaling. Does that make sense?
So it's the same vehicle, but now you just increase the seating capacity.
Exactly. It's the same vehicle, you increase the capacity. But for horizontal scaling, you now have, rather than having one vehicle, you've decided to call 3 or 4 or 5 taxis to come and pick you up. So now you're scaling out because you're increasing the number of number of entities that are there.
Okay, understand. So basically, I mean that the vertical is just one machine, but you tend to maybe increase whatever area, like maybe if it's the storage is the issue, you increase the storage. If it's like you say, maybe the RAM, you increase the RAM and all of those things, but just with the same machine.
Okay. Exactly. Say you have a database that is running on this server. If that database is running on this server, and then that database, maybe you had a few employees, 10 employees, but now your business has boomed. You have 100 employees in 10 different places. So you end up with 1,000 employees. You have to be able to increase just the size of the database. So you add more RAM to it and it should be good. Does that make sense?
That makes sense. Okay.
Very good questions. Very good questions. So keep up asking more questions. That way every doubt is clarified. Gilbert, do you have a question?
The question that Frederick he asked clarified a little bit, but I just want to ask again concerning this adjusting the power CPU. The CPU, in other words, can it also be the virtual machines because CPU like central processing unit?
Yes. So again,
we are adding the CPU.
To answer your question, let me try to put it this way. Let me escape from this. The way the computer is built, like I explained earlier, let's see if I can find my annotator, so I can annotate a little bit. So your computer, obviously, is made up of hardware and software. So in the computer, you have a CPU. A CPU is a processing unit. Everything that a computer is about is like the brain of the computer. So it's that chip, central processing unit. If you know that you're going to be, so pretty much what's a computer? A computer is just a machine that helps us process information faster or computations faster. So what it would take us 1 minute to do a calculation, it would probably take a computer 1 second or a lot less. So the number of the speed at which it can respond to your instructions, because at the end of the day, when you type questions in the keyboard, it's being sent to the CPU. The CPU gets back to you depending on the speed of the CPU. If it's 1 gigabyte or I don't know, 20 gigabytes, then it tells you how fast the CPU is running. But the RAM on its own, the RAM is where you store your instructions or data or whatever else needs to be acted on. Okay, so when you're increasing the CPU, you're increasing the speed at which you can answer these instructions. When you increase the RAM, you're increasing the amount of data that you can store within that server or that machine. Does that make sense?
Makes sense. So in other words, you're saying that the virtual machines, all they have the CPU.
Yes. So normally your physical machine, let's say your physical machine comes with a CPU of 100, right? 100 gigahertz or whatever unit of measurement. Instead of having that physical computer using all that 100, you allocate 20 for one virtual machine and maybe 20 for another virtual machine.
Okay.
Right? To be able to run processes on a different operating system. Now you run out of processing power in there, you need to increase it. In order for you to scale it up, you increase that 20 to 25. But if you want to scale out, then you have to buy another virtual machine to put in that place.
All right.
Make sense?
Yeah.
Awesome. Good questions. Very good questions. What other questions do we have? None? All right. So let's jump back to our presentation and go from there. So we've talked about those two. The first one we talked about was the high availability. Make sure that your system is always up and running. The second is scalability, to be able to handle demand. Whether demand goes up or goes down, we are good to go. It does it on the fly. We don't have to go and buy additional hardware or go and call somebody to come and set up some things on the system. You set it up to go automatically or manually if you want. Next up is reliability. I know we took a look at a little bit at how these data centers. Yes. Go for it. I'm listening. Breeze, can you hear me?
Yeah, GK, please, can you come back on the
I hope I didn't lose him. These guys calling from back home, it's really difficult sometimes with their connection. They just get kicked out. I feel sorry. But you're on mute. Are you asking a question? All right, I believe not. So let's carry on again. Reliability is the next thing. Reliability is huge because it's one of the 5 pillars when you talk about Microsoft Azure's well-architected framework. So the framework, again, we all know what a framework is, just like those scaffoldings that you build around a building when you want to build it up. So framework holds things together. So the framework in this case, we have a decentralized design. All your data is not stored in one location. All the data on the cloud is not stored in one location. It's stored in many different locations. So the ability for the system to recover after failures and continue to function is very, very important. It makes it reliable for you. Okay. So if there's a flood in one area, or there's no power in one area, or there's some physical damage that has been done or catastrophe that has taken place, and one of the data centers is down, that's fine because all the data is replicated on other data centers. So that decentralized design, actually deploying our data centers all around the world, South Africa, Europe, South America, North America, Asia, and so on, it makes it very reliable and resilient. And we can peacefully use it and not have to bother about everything going down or some catastrophe affecting our access or our service. Sounds good? Any questions on this subject? Good. So like I said, there are 5 major pillars: reliability, security, cost optimization, Operational excellence and performance efficiency. We're going to see another one shortly, which is number 4. And that has to do with predictability. As you can see, this guy is walking around with so much confidence, right? So at the end of the day, when you're using the cloud, your benefit is that you can move forward being confident that you have very good performance and you have very good cost. You're not going to have any surprises in terms of the performance of the service, no surprises in terms of the cost of the service. Why are there no surprises? Because of the performance. Performance predictability is also being provided to you by high availability, which we just talked about, because your system is always going to be up and running based on the SLA. There's also going to be load balancing. If you have those 3 servers that are handling your request, and one of the servers gets too bogged down, gets too many requests, your load balancer is going to divert the traffic to the second one. If the second one gets too busy, it diverts it to the third one. If all 3 get too busy, guess what? You also have auto scaling. You can decide now to scale out and create another virtual server that's going to handle it. Or you might scale each one of them up to be able to handle more requests. So that makes sure that your performance is good and your system is not going to go down. With cost, we talked about a little bit in the assessment. You can forecast the cost of the amount that you're going to spend, right? Once you try to create a resource, it tells you what it's going to cost at the end of the day. You can also track and monitor your resource use in real time to tell you, if it's in the middle of the night, to tell you, hey, the demand or the requests are going to up, and you can adjust it. You can use data analytics to find patterns and trends and say, hey, during Christmas season, there's always high traffic. During summertime, the traffic drops down, and so on and so forth. You can adjust it accordingly. But the 2 main tools that we'll talk about again later on at the end of this class, because that's when we'll talk about cost, would be total cost of ownership, which is abbreviated by TCO, and the pricing calculator. Pricing calculator helps you to get estimates on the cost of your cloud computing resources, or you could also use total cost of ownership if you want to move from on-premises to the cloud. It gives you an idea how much it will cost, an estimate, and then you can decide if you want to pursue it or not. Sounds good? Any questions? So we've talked about reliability and predictability. So predictability again, performance predictability, as well as cost predictability. The 5th thing we need to talk about, oops, did I go too fast here? The 5th thing we have to talk about is governance and compliance. Governance and compliance just have to deal with standards, rules, policies, all those other words you see out there. So what you have in Azure is a set of templates. You can create templates, or you can use templates that are already out there to ensure that when you deploy your resources, they comply to certain things. For instance, if it says that every user should have multi-factor authentication, there's a template out there already for it. You just use that template. It's going to set it up for you. You don't have to manually configure everything. So using those templates helps you to be able to meet all those, regulations that are put in place. And if you're using a template, you can go ahead and update that template. It's going to update all the resources that have been deployed with that template, so you don't have to manually do it. So it makes compliance be very easy to handle. And this is a big thing, especially if you're working in, say, financial industry, health industry, military industry. All those things have to be compliant because they are highly, highly checked and audited. So audit flags can also be put in place that will notify you and say, hey, this is out of compliance. For instance, this person is logging in from Africa when we don't have any customers in Africa. This probably a threat or something like that, and then you can shut it down. Or you're expecting customers or your clients to be using the resources between 9 and 6 or 8 and 5, but then you have high requests coming in at 10 p.m. at night. So all those flags can be set off to be able to make sure that your compliance is in check. So there's also mitigation strategies that are provided that will tell you, hey, in order for you to create this resource, you might want to use this and that to be able to make sure that policies are being met, the rules are okay, and so on. And one other thing, to stay up to date, to be compliant, to make sure your requirements are good, patches and updates are always automatically applied for you. So you don't have to try to find an employee that's going to do that for you all the time, or try to set up time to make sure within your schedule to do that. You can use your time for other things since this is automatically taken care of. Sounds good? Questions, concerns, comments? Nothing? All right. Yes, go for it.
Yeah, I just there's this point, the auditing flag. Is it like they're auditing the company, or I
Yes,
understand this one?
yes. So auditing flags, again, what is an audit? Is just checking that everything is in place, everything is compliant, it's in compliance with what you expect. So if you know that you want to make sure that, let's see, what example is it? Say in your taxi, you want to make sure that the taxi can only carry 4 people and 1 driver, and you realize that there's a taxi that's carrying 6 people. That's going to set off a flag and say that, hey, this is using outside the scope or the standards of experience. So it will let you know that, hey, the resource is out of compliance. You need to make sure that it fixes itself, or you adjust it, automatically, to make sure that that compliance is met. Does that help?
Yes, and then we talk about reliability.
Yes.
We said that resources are deployed in all around the world.
Yeah.
Yeah, I wanted to know if is there any, since the resources are deployed in the servers all around the world to ensure that it's reliable, is there any let's say data protection law that protects the information?
Very, very good question. And from your question, we can tell that you're from Europe. You're not one of those of us here in America. We don't care too much about that. But yes, we'll talk about that tomorrow. That's going to be what we'll talk about when we talk about, when we address core architecture models in Azure, the core architecture of Azure. Because in that case, we'll talk about the different regions, because saving stuff in the US is different from saving it in certain areas. So there are sovereign regions. We'll definitely come to that. That's a very good question. And I'll clarify it very well when we get to that part. Sounds good?
Yeah, okay.
Yeah, because there are some places that we cannot just store data at. All right. What other questions do we have?
Vitus, I have a question, and the question is going to go back to a previous
That's fine.
chapter. Yeah, I'm still going back to that very horizontal and vertical scalability, right?
Yes.
So I'm trying to envisage a situation where you choose one option over the other. You understand?
Yeah.
Like you choosing to go horizontal rather than being vertical, or choosing to go vertical rather than being horizontal. So I'm trying to envisage whether, like, being horizontal, it means you have a decentralized, you're trying to decentralize your, maybe like your cloud services, where maybe you could have like the main physical computer, let's say in one static location, and then I choose now to create virtual machines now in maybe like in other areas, you know what I mean, which is a little bit distant from the location of that virtual machine, as compared to the vertical scalability, which you have just one physical machine where you're just either just increasing the size of whatever unit you need inside that machine. You know what I mean?
Awesome. So let me go back again to that example we did. So for instance, you have a bigger family now, the taxi is not going to fit everybody. We decide that either do we want everybody to get into a bus, or do we want to just get 3 different taxis to carry everybody? It depends. If it's just one adult and 10 kids, then you cannot be separating the kids to go into a taxi separately. The best bet would be vertical scaling. But if it's 5 adults, then we really don't care at that case. Why did I use that example? Let's say, for instance, if this resource right here is, let's say, a database server, it will be advisable, depending on the type of database, to save everything on one server. So what you might want to do is to scale up, add more, let's say RAM in this case, to be able to handle a bigger database. But if it's a web server, for instance, then you might just say, you know what, I'm just getting resources on the web. What are some of the resources you need for the web? A picture, a video, image, those files that are being used to serve up the web page. You can decide that, yeah, we don't really need everything to be in one virtual machine. Let's go ahead and spin up another virtual machine. And then we have a load balancer that's going to be able to handle the requests between them. So it depends on the scenario in point. So say, for instance, in the assessment, not the assessment, in the certification, you're asked, hey, you have a web application that was served up and you're running out of capacity. And they really prefer to use a separate web server in this case. How would you go ahead to address this issue? Are you going to scale it vertically, or are you going to scale it horizontally? In this case, they have mentioned that they need a separate server. They need a separate instance. So definitely you want to scale it horizontally because you're adding a new virtual machine. Does that answer your question?
Oh, yeah, kind of, yeah.
Awesome. Very good question. And we are definitely going to
Can you come back on that example again?
Yes, so the example again, his question is, how do you know if you should be scaling up or you should be scaling out, or if you be scaling down or scaling in, right? Say there's a lot of requests coming in, and then you cannot handle it, obviously, with the status quo. You decide that, okay, if it's a database, you want to have all your database components or database objects in one place, then it will be a good idea for you to scale vertically. Add either the RAM in this case, or if the system is slowing down, you want it to go faster, add the CPU. Okay. But if the problem is traffic, let's say traffic is going too much, the traffic is going, yes.
So yeah, can you come back on the difference between CPU and RAM?
Oh, your line is breaking up a little bit. Can you repeat your question?
Yeah, I said, can you come back on the difference between CPU and RAM?
Okay, the difference between CPU and RAM. So again, what is a computer? A computer is just a machine that takes instructions from us and performs the instructions. I always remind people that people mistakenly say computers are smarter than us, or they're going to be smarter than us. That's never going to be happening anytime soon, because computers are just fast but dumb. They are just very fast in processing what needs to be done, but they are very dumb in making decisions. If you tell a computer go left, even when you want it to go right, it's going to go left. So what makes a computer fast is the CPU. The CPU is a central processing unit, that chip, that microchip. In the beginning, it was done with magnetic cables and so on. So it was very hard for us to get faster computers because they have not discovered ways to get those microchips made. So later in the 80s, 90s, microchips started being made. And then we started having Pentium 5, Pentium 3, Pentium 2, and so on. And now it's getting smaller and smaller. So our computers are getting smaller. Most of that is because of the CPU. Back in the days, the CPU would be this big. It would be filling up an entire room. To get one computer, you need an entire room with cables that are connecting capacities or capacitors that are being used up and down. But CPU is the brain of the computer, if there's anything like the brain. just because it's fast. It's very fast in using those those electric switches to be able to go on and off ones and zeros to be able to give you the result of your instruction. The RAM on its own is random access memory. It's a memory. So that's where you save information. Even though we are giving a bunch of instructions, the instructions go and be saved in the RAM. The RAM provides the instructions to the CPU and so on and so forth. So the RAM is like the storage that needs to hold the information between the CPU that processes it and the input or the output. Does that help? I think we cannot hear. So does that answer your question?
Yes, sir.
Okay, so I'll go ahead and also send you a link to one of those videos that I did earlier last year talking about the differences between software, hardware, and their components. That's going to definitely help you to understand, because in this case, everything we're talking about is the hardware. We are scaling up the hardware or scaling down the hardware, or scaling out the hardware or scaling in the hardware. Sounds good? Awesome, awesome. So let's carry on. I think we were at number 6. Number 6 had to do with security. So everybody is good with governance and compliance, right? I believe silence means yes, because everyone is on mute. If you're not, you can unmute and let me know. Yes, Egbe. All right, so let's talk about, we're almost there. We're almost at the end of all these benefits. Security. Security, again, is a huge benefit, and it just comes second nature. Why is that? Because what is the definition again of cloud computing? Can anybody tell me? I think Egbe gave us a very good definition yesterday, but Gilbert, go ahead.
Delivery of cloud services over the internet.
There you go. It's as simple as that, depending on what service you want. If your server is using files, you're delivering files. If your server is saving a website, it becomes a web server. If your server is saving a database, it becomes a database server. If it's, firewall, it's a firewall server. There's all different types of servers. There's even a print server. There's also a fax server and so on. So if cloud computing is in essence delivering all these services over the internet, that means their primary goal was making sure it's secure. So the only part that we have to decide on now is we have a choice to choose. How do we want to manage the security? Do we want to use infrastructure as a service, which is just going to give us the hardware and then we will have maximum control of our security? Or do we want to have less control of our security? We just trust that, hey, you know what? Amazon Web Service or Google Cloud Platform or the Microsoft Azure, we trust them enough. They're already set up. They've shown us their SLA. We know that their platform as a service is going to work just fine, or software as a service is working just fine. For instance, an example of software as a service is Gmail, right? Nobody has a server in their house that they are using for their Gmail, but we trust Google that nobody is going to get into our email. So we're using Google server that's located all around the world to be able to save our emails in a server somewhere on Google Cloud. So that's an example of us choosing that as the security. Now, we know obviously that banks, financial institutions, right, health institutions, and also military institutions, they probably don't trust their data to be out there. So they might want to set up infrastructure as a service. So if you're going to work in any of those cases, you will most likely be dealing with infrastructure as a service at some point, because they want all their data to be in-house, all their hardware to be in-house. Because like we said again, the data can be breached either physically or through the web and different other ways. So We'll talk about defense in depth later on. But with this, you have the option of choosing how you want to manage your security.
Yeah, I have a quick question,
Yes.
Vitus. Like your email, that is software as a service, right?
Yes.
Okay. And the software as a service, I mean, your email now, as far as security is concerned, it's basically ensured by the provider, right?
Yes.
And then why is it that sometimes, I mean, how strong is that level of protection by that provider, considering the fact that sometimes we get some spam, I mean, some hacked, I mean, some kind of compromising email sent to a personal email, which when you open, you know what I mean, then it takes control of your email and things like that. So why is it that possible that the provider can't really give you that sufficient protection, or there's always kind of a lapse in every circumstance?
Very, very good question. And this will be a good question for Blazo or Egbert to answer, because those guys have experience with cybersecurity. But I'm going to try to answer it for you. Okay. So with cybersecurity, that's what we are talking about here when we talk about spam and so on. There are different types of threats. There are physical threats, there are malware. Malware, again, is just short form for malicious software. The malicious software comes in many different types. And then you also have social engineers. Social engineers are, in other words, scammers, right? Social engineers, they take advantage of you and they have their principles and so on. They either get some kind of urgency, or they use some other threat, or, different techniques to be able to approach you and fool you to grant them access. The only way this is possible is if you grant them access. You can have 1 million people sending you spam email. As long as you don't open it, they will never have access to your email. But the moment you start giving them your password, your personal private information, then you're giving them access to it. That's why you hear Google, Yahoo, all these all these email providers, they'll tell you, we will never request a password from you or any personal information. You're taking it and saving it in there. The only way anybody's going to get access is if they trick you. They use social techniques to engineer you into giving them that information, and then they hack into your system. Does that make sense?
No, but, yeah, maybe, but I remember there was a time that I know that, okay, if you don't give them your password or access to your personal information, but there are times where an email can come to your box and then you open it. Maybe opening that email is also another form of you giving the access.
Exactly.
Because as you open it, and then you realize that the email has been sent to so many people.
So like I said, right, not to cut you short, there are many different techniques. There are many different ways that it can be done. Even with your browser, even with you downloading software that you're not supposed to download, even with you just going to a different website, they get access to your website, they start monitoring your keystrokes and so on. So at the end of the day, this is a whole different topic, which is not something that we can cover today or even in a week. But there are many, many different ways. At the end of the day, all you want to do is, if you get an email from someone that, they might be faking it and giving you my name, but the link is something else, and so on and so forth, you just have to not fall prey to that. That's why I discourage people from forwarding all these forwarded messages up and down, whether they are true or they are not. Don't forward messages all around, because I could create a malicious website, forward a message to you with a link, 10, 20 people click it, it becomes something else. So that's a whole different topic on its own. But that would be a weakness that is going to be something that you propagate. So viruses are usually effective only when there's human interaction. If a human does not click a button or does not go to a website or does not do anything, then it's not going to happen. So again, that's a whole topic that I can take 3 days to talk about it. But it's beyond the scope of this class, so let's not go into it. But in the same light, There is an example, as you see on here, robust and secure. We're talking about distributed denial of service. What is distributed denial of service? So denial of service attacks, an example I can give you is, let's say you go to a bar and you order a beer, right? The bartender goes and grabs a beer and gives you back. That is how a request usually goes on a website. One person clicks on a link, it sends a request to the server grabs the resources that it needs to grab and bring it back to that person. But if you have 10 people requesting for beer at the same time, what's going to happen to the bartender? The bartender is just going to crash and burn, you know. So imagine somebody knocking on your door, maybe a Jehovah's Witness, you open the door, and then after 10 minutes, another person knock, and then the whole crowd is knocking on your door. You would end up not being able to serve all of them. You deny them service. So denial of service is an attack that is very prominent on websites, but then it gets a step higher, because instead of you refusing to give me 10 drinks because I keep asking, give me a drink, give me a drink, give me a drink, and you get tired of me, now I have 10 of my friends that come. Those 10 friends are also asking, give me a drink, give me a drink. It becomes, you know, the effect gets multiplied, because you probably decide that since this crazy young man keeps asking for beer, I'm not going to serve him anymore. But guess what? I go back and I talk to 10 people, give them a tip. Those 10 people come and also start asking. So that's what distributed denial of service is, because now you have different requests coming from all over, and then you deny them service, and then your website crashes and goes down. Now nobody can request beer anymore. Nobody can enter into your house because you have decided to lock the door, because all those requests are fake and it's eating up all your resources. So does that make sense in this case? So the reason that distributed denial of service is handled very well with the cloud is because it's a service that's provided over the internet by default, naturally. So they create a network that is more robust and secure to handle that. We'll talk about the network next week, because those are the three main services that are provided by the cloud. The compute network, the compute service, which has to do with the CPU, right? Computing things. The network service or networking service, which we're going to talk about in depth, as well as the storage service, which, like we said, talking about the RAM and the different ways in which you can store data on the cloud. Sounds good?
Yeah.
Yeah.
Yeah, so these are all things that make you benefit from using a cloud. Imagine that you were using your server locally or in-house. If you're using it in-house, you will probably not be able to handle distributed denial of service. You will not be able to handle different levels of security. You would probably just have a very difficult time managing that. Now, finally, the last one, or the last major benefit, is manageability, meaning you're able to manage things off the cloud and things in the cloud. On the left-hand side, you can see we are talking about the management of the cloud. With the management of the cloud, we are able to automatically scale based on the need, like we have talked about. We are able to deploy resources based on pre-configured templates. Like I said, you have templates that you can use that, you know, can manage things for you and make you compliant. And we're also able to monitor the health of the resources. So you're checking for your virtual machine, you're checking each of the resources and all those other resources, the website that you're deploying, so that you can automatically replace anything that is failing. For instance, that distributed denial of service. So that monitoring that takes place to check the health of your resource automatically replace anything that is not working correctly. Finally, you can also set up alerts, right? That will be based on a configuration metric. For instance, if I'm getting up to 80% capacity of my RAM, send me an email, send me a text, send me a notification. Or if I'm getting to 80%, increase it. You know, so all those alerts, the automatic replacement, the scalability, the use of templates help us to be able to manage the cloud. So that's the one option of it. The other is, how do we manage things ourselves in the cloud? In the cloud, you can decide to use the web portal. Okay, these are some of the things that I asked you to read up on it yesterday. So the web portal, what is a portal? A portal is like a bucket, right? A bucket or a basin or whatever that's holding things together. So that portal is what carries all your resources. We'll talk about it very well tomorrow. So whatever resource you want to deploy, they are all found in the portal, and you're using a website to get to it. So that's a web portal that can be used to manage things in the cloud or manage resources in the cloud. If you don't want to use the portal, because the portal is the front end, again, front end versus back end. Front end has a graphical user interface that you can see clearly, it looks nice. The other option is using the back end. The back end has a command line interface, what you mostly see as a black background or a green background. That's CLI, stands for command line interface. So Azure uses that, or Azure also uses PowerShell. PowerShell is another version of the command line interface that's used by Windows machine. So Windows machine uses CLI, and the bash is used by Azure CLI. But we'll talk about that as well in depth tomorrow. But another one you might want to use is APIs. All of these are interfaces. What is an interface? An interface, again, is just something that separates two faces, right? So for instance, application programming interface separates two applications. One application needs to talk to the other application, it uses an API. So the application programming interface is the bond between those two interfaces. The command line interface is the interface between your application and the hardware. Hardware, again, whatever you're using to input, maybe voice, typing, or picture, and so on and so forth. So that's what an interface is in a nutshell. Does that make sense? So those are all the ways that you can manage a server. With that, I'm going to give you a quick quote to clear your brain a little bit. And the quote here tells you, technology is anything that wasn't around when you were born. I don't know how far that is true, if everybody is in accordance with that, but I think that's pretty neat, right? So that's it. What do you have to add, Mr. Fred?
No, I'm just saying, it's a technology is anything that wasn't around when you were born. I think it makes sense in the sense that technology is very dynamic. It is not static. So
Exactly.
you are born today with the current technology, and then by tomorrow you realize that, okay, you're entering a new phase of technology. So it changed constantly.
I know. I mean, think about us back in the days when if you go to school with a Walkman, everybody sees you like a star. I
Exactly.
mean, the first time I bought a diskette was in 1995. I was proud of myself that, man, I have storage that I can store stuff. I can type it, an email. I was a star, actually, even at UB. I would take my diskette and use it on the computer, type everybody's email. When we go to the cyber cafe, I just put the diskette. In 2 minutes, the email is sent. And they'll be like, wow, instead of paying 100, 200, 500 per hour to be able to type a long email, you bring your email, I type it all up for you in the diskette, and I go and post it. On the way
floppy
back,
disk, right?
yeah, floppy disk, the
Yeah.
diskette. On the way back, you just buy me one corn and give me 2 plums, and I'm good. The next day, you find something else to eat. So that was big. That back then, that was technology. And then you have CDs, DVDs. Nobody even uses CDs and DVDs today. Everything now is, YouTube, and I mean, even iPods, they are not even in use anymore. So that's how much technology moves really, really fast. All right. So we've been going for about 1 hour so far today. It's about 15 minutes after the hour. But at this point, I believe we've covered everything that we needed to cover, right? We've been able to describe the benefits of high availability and scalability. We also talked about reliability and predictability. We talked about security, governance, and finally, we just talked about manageability. So what questions do you have for me? Does everything make sense, or is there anything that was problematic? No questions? Well, today is going to be a short day for you. I'm going to give you guys back 1 hour to go ahead and review everything that we have done, because this is the end of the first section. A few terms that I would like you to also remember. We talked about high availabilities, usually shortcut is HA, and uptime, SLA, scalability, horizontal and vertical scaling, which could be either up, down, in and out. Reliability, again, it's one of the Microsoft Azure well-architected framework pillars. Predictability, that has to do with performance predictability and cost predictability. We talked about security, governance, and compliance, as well as manageability. Some of the tools that we'll be looking at are also outlined out there. You can research more on that. Tomorrow, we're going to jump into the next domain. So far, we've been able to cover about 25 to 30% of the content that you will be seeing in the, not assessment, I keep trying to say assessment, the certification exam, okay? So I am going to come up with...
You mean certification for cloud fundamentals, right?
Yes, for cloud fundamentals.
For Azure, Azure fundamentals or cloud fundamentals?
It's Azure fundamentals, AZ 900.
Anyways,
yeah.
Okay.
So again, all of that is in our information on our website or on the classroom. I will be adding a quiz on Wednesday. That quiz is going to cover the areas that we've talked about, okay? So if you look at the certification material, let's click on this. I think it should be about page 17. Let me go down here and change it to page 17 so that we can take a look at it. Why can I not type? Am I typing in here already? Or am I not? Okay, that's fine. I'm just going to scroll. All right, there you go. So that's AZ 900. Let's make it bigger so everyone can see it clearly. So AZ 900 has these 3 skill sections.
Yeah, I have a problem.
Okay, that are measured. We are done with describing cloud concepts, so you guys should be good with that. Tomorrow, we are going to talk about Azure architecture, and then next week, we're going to talk about Azure services. Those services that I pointed out to you: compute, networking, and storage. That's what we'll cover next week. And then the following week, we'll talk about management and governance. And after that, you should be good on your way to take the AZ 900 exam. Sounds like a plan?
Absolutely.
All right. What other questions do we have?
DK? Yeah, DK, I was unable to open most of your courses online, the link you sent to me. So I don't know.
Okay, so are you able to share your screen? Let's see if we can address the issue.
Let me see.
Yeah, if you can share your screen, then we can go ahead and try to address the issue. But you're talking about on the Google Classroom, right? Are you there? Okay, so while you're getting ready to share your screen, does anyone else have any questions, Mr. Egber?
Yeah. I'm trying. Listen.
Okay, so
They're telling me it's impossible for me to share my screen. I don't know why.
okay, I stopped sharing mine. Try sharing it again. Let's see. Oh, you know why you're using? Are you using an Apple computer? Can you try it again and see if you can share it this time around? Okay, we cannot hear you. So I think I might set up some time with you afterwards and then we can work on it and to make sure that you have
Yes,
access to everything. Does anyone else have questions that they would like to address? Yes, go for it.
yes.
No questions? Gilbert, are you good? All right. So if
Can you hear
everybody
me?
is good, then
Mhm.
yes, I can hear you now. Go for it. What's your question?
Let's see. I'm using
Are
an
you still trying to
iPad.
share? Is it possible?
That's one.
Yes, please.
For me? Yeah, I'm trying it.
Okay, so are you using a Windows
Sometime.
computer or a Mac computer?
I'm using my iPad Pro.
Okay, so that's
So
you probably have to go ahead and change the settings to be able to accept that whatever software you're using should be able to present its screen. So it has to do with some of your security settings. So without that, you won't be able to present. But that's something we can take offline and then I can help you to figure that one out. Sounds good? All right. Welcome back, Mr. Ngo. I know you're having network issues, but the call is being recorded, so I'm going to share the recording with everyone else. So,
Yeah, I'm good.
Reese, are
I'm
you
good.
good? All right. Anybody else have a question? Because we're about to round up. Again, quick recap. We've been able to, let me go back to what we have covered so far. We've been able to complete everything under cloud concepts. So the cloud concepts, let me go back. Yes, Reese.
good.
Oh, sorry, I think there's a lag when you speak. So let me go back to our Google Classroom. If you go to the Google Classroom, where you have sessions schedule, if you click on that, there should be, I thought I added this in here, maybe not. That's not good. Okay, did I add it somewhere else? No, it's not in here. All right, I'm going to double check it. Let me just go ahead and check anyway. If you go under classwork, I should have a class drive folder. I know it should be in there. Yep, Azure Cloud Fundamentals. So this gives you a little breakdown of everything that we needed to cover, right? So let me go ahead and make this bigger. That way everybody can see it clearly. Okay, so today is the second day. We're able to talk on cloud benefits, right? So we've been able to cover cloud service benefits, which is actually part of cloud concepts. So we are all good with that. Yesterday, we were able to talk about cloud computing and the service types. That's infrastructure as a service, platform as a service, as well as software as a service. So we're all good with those. So for now, we're done with the first domain, which is describing cloud concepts. We can go ahead and take a small demo on Azure, but I'll prefer to do it on Monday because that's easier for you to grasp just before we jump into Azure core architecture. After we talk about Azure core architecture, we'll then talk on Azure compute, Azure network, and Azure storage services. Those are the three main services. Then we'll talk about identity, access, and security, Azure cost management, which we've talked about all of those, just in passing. So we'll talk about them in depth, and also finally get to Azure governance and compliance, Azure management and deployment, and those monitoring tools, like the monitoring tools for auditing and monitoring tools for health, and security, and so on. And by the 27th of March, we should be ready to take a few recap tests. So, like I said, on Wednesday, every week, I'm going to have a quiz set up for you, send you an email or a link. Might be 10 questions, 20 questions, it depends, or multiple choice. Since we've covered the first domain, everything is going to be focused on the first domain. Once we're done with the second domain, I'm going to have another quiz for you guys, and then we can go ahead and have a final quiz at the end of the day. Sounds good?
Yep.
All right. So no questions. We've gone over 1 hour. I usually try to give you guys a break. So instead of having a break, we're going to end class early today, give you some time to gain access to all those notes that I've given. I'm also going to upload a video very soon and catch up so that tomorrow, Monday, I'm going to be available all day. You can request an appointment. If you go to the website, there's a link in there for you to request an appointment. So you can join the class live with this link or with the blue button, or you can request to make an appointment. If I click on this, it opens a window where you can select to have a 1 hour appointment or a 30 minutes appointment. This notifies me so that I'm able to set time aside for you, and I'm not going to be doing anything else, so that you have to be dedicated to helping you. So if you click on 30 minutes, this is Monday, tomorrow, you can see the availability is pretty open. So you can choose whichever time works for you. I'm in Detroit, so it's giving me Detroit time. When you click on it, it's going to give you your own time that matches with my time. All right. So every Monday, I'm available most of the day, except when we have class either at 2 p.m. or at 6 p.m. So I know 6 p.m. will be challenging for people in Cameroon. So if you're available earlier, we can do it the same this time that is being done now. But on Tuesday, Wednesday, Thursday, and Friday, I will not be available during the day. I'll only be available at night. Sounds good?
Yeah.
All right. So final call for questions. If you don't have any questions, then we can call it a day. And again, if I decide I want to make an appointment, all you have to do is enter your contact information and your email and book. That's it. And you're all done.
So our next class is going to be a session number 3, right?
Yes. So let's go back in here. Our next class will be session number 3, which is going to talk about core architecture. So if you go also back to the website, you should be able to see that it's already on there, but I don't have all the slides ready. If you want to always go ahead of time, next week I'm going to put all the content in there. But if you want to go ahead of class to review before class, right now I'm clicking on architecture, Azure architecture, core architecture. If I click on the curriculum, it's going to give me an idea, a sneak peek of what I'm going to be covering tomorrow. So let's click on that. You'll be able to see that obviously all the slides are not updated yet, but it gives you an idea what we'll be learning. We'll be learning about the physical infrastructure and how resources are managed. We're also going to address these would be our goals. So the regions that Gilbert asked about, we're going to talk about them tomorrow. We'll talk about Azure regions, region pairs, sovereign regions. We'll also talk about availability zones, data centers. We'll talk about our resources, which is where we're going to spend most of our time, how we have resource groups, subscriptions, managing those groups, and the hierarchy of all of these. And that should be all for us, but we're going to look at a lot of things. So you can go in there, take a look at it. You don't need to understand all of that. Look at all of that. It's going to give you an idea of what we're going to cover tomorrow. And so, sounds good?
Yeah.
Sure.
Awesome. All right, let me let you guys go. It's 29 minutes after the hour. And let me know if you have any questions. Otherwise, see you tomorrow at 6 p.m. Eastern time, my time. If you have time at 2 p.m., you would like to go through this earlier than everyone else so that you don't have to attend late at night if you're in a different time zone. Let's talk about that later. Sounds good?
Yeah.
Oh, for some of us who will only be free, well, I'll see. I'll only be free maybe like after, I guess, 4:30 or 5:30.
Yes,
No,
our
that's
class
my
tomorrow is at 6.
no. That's my mountain time. I know you have Eastern time, so
Oh,
we're
that's
2
right.
hours.
That's right.
We're 2 hours behind you. So, but it's okay. I'm
That's
2 hours
right.
behind
That's
you,
right.
right? You share the same time with Eastern,
Yeah, with New York.
with Toronto,
Yeah.
yeah, Montreal, the rest, yeah.
Yeah, so we can if it doesn't work out, we can always see how flexible we can be. Maybe
No,
move it
it's
to 7,
no,
depending
it's
on.
okay. No,
Okay,
you don't have to do it just for my sake. At least there are other participants, so I can always catch up. It's not a big deal.
understood. And the recording is also available for everyone.
Yeah.
All right, guys, have a wonderful day. It's 30 minutes after the hour. I'll see you tomorrow.
Yeah, Victor, I just wanted to ask you something, but it's out of the class, so maybe this is something personal. I would like to get a chat with you. I don't know if we'll
Okay,
communicate.
then you can call me and then we can talk
Okay.
about it.